A flagpole is bent over at a point 4/9 of the distance from its base to the top. The top of the pole reached a point on the ground 9 meters from the base. What was the original height of the pole? So originally we had a flagpole that was standing up nice and tall, had a flag on it, and then at some point it broke. Here, 4/9 of the height up. So it was longer up here than it is down here. Also, when you put a flagpole in the ground, you usually put it in at a 90-degree angle so it stands up nice and straight and doesn't break. But this tip actually broke, and the pole is now laying on the ground over here. And it's on the ground 9 meters from the base. Well, how long is this piece that's laying here diagonally? If the total height, h, has been cut into a piece, the remaining piece must be 5/9 h. So you can see here that we have a right triangle. Let's use Pythagorean Theorem. A squared plus b squared is equal to c squared. And we'll put in the values we know for a and for b and for c. Our altitude, a, is 4/9. Our base is 9. And our hypotenuse, the part of the triangle that does not touch the right angle, is 5/9 h. So let's square each of those. We'll get 16/81h squared plus 81 is equal to 25/81h squared. We have h on both sides of the equation. Let's put those together. We'll subtract a 16/81h squared from both sides. 81 is equal to 9/81h squared. Well, that can be reduced. 81 equals 1/9 h squared. Solving for h, we can multiply both sides of the equation by 9. And that'll give us 729 is equal to h squared. And then we'll take the square root of both sides. And that will give us 27 equals h. But the question is, what was the original height of the pole? And this h is representing the height of the pole. Remember, we said it was a piece of the pole that was left standing here. And so h is our height. The answer to this question is 27 meters.